Welcome back, guys. We're going to be dealing with something called domain today. You may have seen this before. Oftentimes it's like domain and range that go together. We're not going to really see range yet, so focusing on this phrase called domain. Now, of course, we got to talk about what that means. What is domain? Domain is a set of any x values which are okay. So if you're given an expression, if you're given an equation, if you're given something with an x in it, there might be values of x which cause problems, especially when we get into more complicated equations. So we're basically going to express which x values are okay, which ones are not, and then we know what to avoid when we are using the equations and such. And we'll use interval notation to set our domain. So for example, if for some reason our problem could only use numbers that were 2 and above, we would use a bracket 2 going off to infinity to say these are the values we can use, don't use anything else, because anything else would be an issue. Okay, so there's two main things that we'll see that cause issues. First and foremost, dividing by 0. So you can't divide by 0. If you're not sure why, I can explain why at some point later, but dividing by 0 is an issue. So any situation that we would have where a variable is on the bottom of a fraction and a value of x would cause you to divide by 0, we have to watch out for that. And we'll say it's okay. So whatever value does that, we'll just avoid it. The second one is that you cannot square root a negative number. Now we have discussed the existence of imaginary numbers, but we won't be dealing with that when we talk about domain. Generally speaking, most people talk about domain as just over the real numbers and nothing else. Okay, and there are other things out there which cause problems. We will talk about logarithms at some point. There's issues with those. There's some other things we'll see that have domains that are kind of strange, but these two are all we're going to start with for now. Okay, so let's start with a few examples. I got a fraction here with something in the bottom that has a variable. So there's some value of x out there which is going to cause an issue. And if you can't think of it in your head, we can basically just solve for it. So you're saying, okay, I don't want all of this to be 0, so let's just make it 0, and then we'll find out when that happens. So here's my equation. Solve it pretty quickly here. Minus 5 from both sides and divide by 2. So you could say, okay, if x is equal to negative 5 halves, this bottom will become 0, and that's what I'm trying to avoid. So don't use this number. That's no good. Okay, so I did say we're going to use interval notation to express this. This is obviously way simpler than interval notation, but we're just going to keep it consistent and use intervals for everything. No matter what we're talking about, if there's inequalities involved, we use that. Okay, so what you have to picture of when you're trying to do this with intervals is that if you just can't use this number, that means you can use anything else besides it. That's basically how you use intervals, is you say, what can I use instead of what can't you? So I can use anything before this number, and I can use anything after this number, just don't use this number itself. So we'll start with negative infinity, and we'll go all the way to negative 5 halves. We'll use a parenthesis to show that you can't use that number, we're just going to come close to it. Then we will do a union, and basically kind of skip over that number and keep going. So both these parentheses show that we're not actually using that value, so it's the idea of getting infinitely close to it without actually touching it, and we'll just skip over that number itself. Okay, so again, this is the inequality, or the just strictly not equal to, is a little bit shorter writing-wise, but everything we do is going to be intervals just to keep it the same across the board. Okay, so if you're given a square root, again, there's no issue this time with dividing by 0. You can actually have the 0 inside of a square root, so that part's not a problem, but we can't have negatives inside of here if we're dealing with real numbers. So it's kind of similar to what we did here. In this problem, we basically just set out to find what caused the issue. We're just going to say in this case, well, I know my insides have to be positive or 0, so I'll say greater than or equal to 0, and I'll set the left side there to what's actually inside the problem. So x minus 4 is supposed to be greater than or equal to 0, and that one's pretty easy as well. Just add 4 to both sides, and you'll have greater than or equal to 4. So in interval notation, just 4 and beyond. And this one's a little bit faster to write than that. If it's a straightforward inequality like this, there's almost no difference in terms of how much you have to write, but that's pretty much it for a problem like this. Okay, so this is about as complicated as it gets unless you mix in the two ideas together. I am going to throw one more weird fraction at you and one more weird inequality at you, but it's going to use these same concepts. So let's try the one with the fraction in it. And you'll notice the difference here is we still can't divide by 0, but it's not a linear factor on the bottom now. It's actually a quadratic. So we're going to start the same way. We're going to say, I don't want this bottom to be 0, so let's make it 0, and let's just find out when that occurs. So here's my bottom set equal to 0. We can factor that, x minus 2 or sorry, x minus 3x plus 2 is equal to 0, which means I can split the problem into two parts. X minus 3 could be 0, or x plus 2 equals 0. And then we get two possibilities, x equal to 3 or x equal to negative 2. And again, those aren't our solutions, those are the things we don't want. So technically speaking, you could say those are not equal to my answers. So it's actually pretty simple. Picture what we did before. We said, okay, I can use anything up to this number and anything after it, just not this number itself. Same with that 3. It's going to be a 3-part integral notation for this one. We'll start with negative infinity. We'll go to negative 2. We'll skip over that and keep going all the way until we hit 3, because 3 was the other problem we had. We'll skip over that as well and keep going. Okay, so skip over each number basically. It's kind of weird to write it this way, but you're just jumping over each point that you can't use. Last example we'll do is the trickiest, I'd say, and kind of the weirdest with how I have to do it. You could start the same way as we did before. Remember, it's inside of a square root, so we'd say all of this stuff has to be greater than or equal to 0. Now, here's the thing that people get mixed up. You could factor it, and then you'd have something like this. In the last problem, we basically just split it, right? We said, okay, we could say this is greater than or equal to 0, or that's greater than or equal to 0. The problem here is that this actually isn't guaranteed to be true. There is a special property with equal to 0, but we can't just throw that around randomly everywhere. It doesn't also apply to greater than or equal to 0. So these are not necessarily true. We do, however, know that something special is going to happen at 3, and something special is going to happen at negative 2. And there's a lot that goes into this. The more we see it throughout the year, the more you'll hopefully understand why this is happening. But the safest way to just figure out the answer is to test things around this number and test things around that number to see what's going on. So I just make a number line, and I put 0 right in the center here. And then I test my other two numbers to see what's going on. So negative 2 over here, 3 over here. I'm just going to check what's happening before negative 2, what's happening between these numbers, and what's happening after 3. I know what's going on exactly at these values. That's when the whole thing equals 0 itself. So there's not too much exciting at that point, but I don't know what's happening before, in the middle, and after. Okay, so let's test something before negative 2. Let's just go with negative 3. So we're going to plug in negative 3 into the problem. We'll have negative 3 squared minus negative 3 minus 6, and all that's going to be square rooted. We'll have 9 minus a negative, so plus 3, and then minus 6. This is going to be the square root of positive 6. So not a nice number when you square root that, but it is at least doable. We can take the square root of 6 and it's fine. So everything over here is going to work. Everything in front of negative 2 is fine. So we'll put a little happy face there. Okay. Next we're going to test in between negative 2 and 3. So let's go ahead and plug in 0. You can plug in 1 or 2 or something, but 0 is a really easy number to test most of the time. So 0 squared, that's nothing, minus 0 is something, and then you get a negative 6. So when you plug in 0, you get negative 6. This whole region is bad. Nothing in here is going to work. You can test other numbers to make sure, but basically you know your critical values. You know negative 2 and 3 are critical values, so anything between them, if one number is bad, they're all bad. And last but not least, let's test the final region here, the 3. So 3 itself is no good, so test something higher than that, like 4. 4 squared is 16. Take away 4 more, that's 12. 6 more, that would be 6 again. So we get square root of 6 again. This region is also going to be good. And if you want to put like a check mark or a sad face for this part or whatever, it's fine. Just something to indicate to yourself that one region's good and the others are bad. Now something else you'll notice is that it alternated, good, then bad, then good. There's a lot of reasons why. Sometimes it alternates, sometimes it doesn't. Almost every problem we do is going to alternate. Okay, so when we get into some later chapters, I'll explain how you can just know ahead of time whether it's going to alternate. But just for now, expect it to, because most of the time it does. Okay, so final answer here, we're going to say everything up to negative 2 worked. And again, we can use negative 2 this time, because square root of 0 itself is okay. So bracket on the negative 2. And then we're going to skip this whole middle region and just pick up with 3 and beyond. So 3 and beyond. Okay, so there are a few more complicated things we'll do with this, but for now, just remember, if you have a fraction, watch out for 0. If you have a square root, watch out for negatives.